Hello class, today we're going to be covering logarithmic functions, and that's basically today's chapter, logarithmic functions. And it's very simple if you understand how to deal with an exponential function. With logarithmic, we're going to be converting from logarithmic to exponential, then converting back from exponential to logarithmic, evaluating logarithms using common logarithms and using natural logarithms. Now, on your calculator, I'm pretty sure you've seen, the word log, right? And let's say we have a log of base b. So this b down here is called the base. Now the input is simply, let's call it c, and it equals to the output, which is a. So we have a log, let's say of base 2, it has an input of 8 equals to 3. Now what does this exactly mean? This means that the base, which is b, if raised to whatever number after the equal sign, in this case it's a, b raised to the power of a, equals to what's inside the parentheses, which is simply c. Now 2 raised to the power of 3 is in fact equal to what's inside the parentheses, which equals to 8. Now we try the following exponential equations in logarithmic form. We have all three. Now we're going to practice with the first one. Now what's the base? The base is 2, right? So you write down log of 2, write down the equal sign. Well, the base of 2 was raised to the power of 3, right? And it equals to what number? It simply equals to 8. So 2 to the power of 3 equals to 8, and that's it. What about the second one? We have log of 5, which equals to 2. So 5 raised to the power of 2 equals to 25. Now what about the last one? Well, the base is 10, right? So write down log 10, which equals to the exponent, which is negative 4, since 10 is raised to the power of negative 4. 10, then you write down 1 over 10,000, since 10 to the power of negative 4 equals to 1 divided by 10,000. And that's pretty much it for the basic understanding of a log. Now, you can practice with these three examples, A, B, and C. Try and turn them into logarithmic form. You've been given exponential equations, you need to convert them into logarithmic form. Now, how do we solve a logarithm, right? Now, we were able to convert from logarithmic to exponential, which is, let's say, log of 4 equals to 16, 2, what did I just write down? Log of 4 equals to 2, 16. This simply means that 4 squared equals to 16. Now this is an exponential form, right? And the first one is checked. The second one is converting from exponential to logarithmic. Well, that's what we just did over here. If I have 2, 3, 8, what do? Let's repeat it really quick. You write down log Well, what's the base? It's simply 2 equals to the exponent, which is 3. So 2 cubed equals to 8, and that's it. Now, we're done with the second one. The third objective is to evaluate logarithms. And to do that, you might be asked to convert from exponential to logarithmic or the other way around. In this case, I have y, which equals to log 4, 64, right? How do I deal with this? Well, it's simply 4 to the power of y, which equals to 64. Now, what number to the power, 4 raised to what power equals to 64? Well, 4 squared equals to 16, right? 4 cubed equals to 64, and that's it. Now, okay, what about this one? We have y equals log 3, 1 over 27. Well, y equals to, let me fix this really quick. Okay, y equals log 3, 1 divided by 27. Well, this simply means that 3 to the power of y equals 1 divided by 27. How do I deal with this? Well, what is 1 divided by 27? Isn't it simply 3y equals 3 negative 3? Where y equals to negative 3, and that's it. It's that simple. Now, you can try and solve this one on your own. You can move on to the last two objectives, which are very simple. We have to use common logarithm, which is, let's say on the calculator you write log. I want you to open your calculator right now and write log, let's say 1000. Well, do you know what this is equal to? It equals to 3. Now, you may ask, how did I find the answer, right? Well, if I write down x and I ask you this is raised to what power, you would tell me it's raised to the power of 1, right? We don't write 1, but it does exist. Let's say I write down square root of x and I ask you what is the nth root. So let's write down square root of x and I ask you what's the nth root of this root, right? What would you tell me? The nth root of x, let's say. You would simply tell me 2. There's a 2 going on, but we don't write it. Now, what about log of x? If I write down log of x, well, what's the base? I don't see a base going on, but there is a base. Whenever you see a log without a base, you must immediately know that the base equals to 10. So if I write down log of x, that means the base does exist, but it equals to 10. And what about log of 1000? And you're asked to evaluate this. To evaluate it, you must place the log equal to x, right? We're searching for the value of this log. And you could place it equal to y, let's say. What do we get? Well, I know that the base is 10. That means 10 to the power of y equals to 1000, where 10 to the power of y equals to 10 cubed, y equals to 3, and that's your answer. It's that simple. Now, last but not least, let's say I have log of ex. Well, e is a value, right? It's the exponential value. If you type in the e constant on your calculator, you're gonna get, I believe it's 2.7 and so on, right? Like I don't remember the exact numbers, but I do remember it starts with 2. Let me double check that really quick. Yes, it is 2.718 and so on. Now, if I have log with a base of e, we don't write it as log. Instead, what do? You write len, which is ln, which is the natural logarithm. And we still have an input of x, let's say, equals to y. And that's it. So in this case, if you see len x equal to y, that means this was log base of e, input x equal to y, which means that e to the power of y equals to x. So len of x is simply log of x with a base of e, and that's it. I hope you get this. And yeah, that's pretty much it for the chapter. And yeah, if you do have any questions, feel free to message me. And yeah, bye-bye.